if we have points x1, y1, and x2, y2, we can sketch the fundamental triangle, with the characteristic that the legs are parallel to the coordinate axes, and the hypotenuse is the line segment joining the points, meaning that these are vertices of the triangle. You afraid I'm going to start dancing or something? Yeah, you know, if I'd have heard that music a little better, you wouldn't have wanted that. Okay, now, so we know that the displacement from here to here is x2 minus x1. Reason being, if the x-axis, we don't know where it is, it could be up there and down here anywhere. Wherever it is, we can project perpendicular to the x-axis and get the point here that has coordinate x1 and the point here that has coordinate x2. And as we've seen in preliminary problems, the displacement from here to here is x2 minus x1. These lines being parallel, the displacement from here to here. And these angles, of course, also being right angles, you need to say that. Okay? Then this is the displacement corresponding to this leg. If we move from this point to this point, remember when we do a slope, we're always moving from one point to the other, right? Okay? So if in moving from this point to this point we happen to have to go down or to the left, the displacement might be negative, okay? But according to this picture, this is what we have. And here, our displacement would be y2 minus y1, and that would correspond to this, a very similar argument. So that, first of all, slope is rise over run. Now we're talking about the slope of this segment joining the two vertices, right? So slope is rise over run. And if we move from this point to this point, from x1, y1 to x2, y2, no matter whether x2, y2 is to the right and up, or to the left and up, or to the right and down, or anything, this is always going to give us the displacement from here to here, and then from here to here. Okay, it's always going to give us two displacements from x1, y1 to x2, y2. It's very important to lock that idea in, because that's one of the fundamental things you have to understand in order to debug if you mess something up with the notation. Okay? Now, that then is y2 minus y1 over x2 minus x1. You will often see this as a formula for the slope between 2 points. I think probably everybody has seen this. Have you? Okay, that's the slope formula, but it has a lot deeper meaning than just a superficial formula somebody gives you. Now, whatever book you were using, if you're using a book, probably explained that, but you might have bypassed it because naturally, with all the things you've got to do, if you can get the homework done without understanding everything in depth, it's going to be a tendency for people to do. Okay? And it's understandable why, but what we want to do here is make sure we understand all the details of why this is the case and why that's the slope. The hypotenuse well, the hypotenuse squared is, let's call it leg 1 squared plus leg 2 squared. Is that clear? That should be, I mean, that's a statement of the Pythagorean theorem, right? Because the hypotenuse would be side C. Now you usually see this as c squared equals a squared plus b squared. Same thing. I'm just calling it leg 1 and leg 2. I'm identifying that A and B are two legs. And the hypotenuse is the side C, and you know that C is the hypotenuse, right? So how do we apply this? this tells us that the hypotenuse squared equals the square root of leg 1. What's leg 1?
Leg 1 is a squared.
X2 minus.
In terms of this picture, it's x2 minus x1, except it really isn't, because x2 minus x1 might be negative, because x2 minus x1 is a displacement, isn't it? And your legs can't be negative, but even if this is a displacement, it's just the negative of the distance, right? So this is either the negative of the distance or it is the distance, and when you square it, it's still going to be the square of the distance. If you square the negative of the distance, you still get the square of the distance, don't you? Because the negatives multiply out. So you have x2 minus x1 squared plus y2 minus y1 squared. Okay? Another thing that you often see as a formula, if you understand the fundamental triangle, I mean, it's always great to remember the formula, but you know why the formula is what it is, right? So, yeah, it's kind of important to understand why it is, because you might forget the formula. If you forget the formula and you're on a test, what are you going to do? Well, if you understand the fundamental triangle, you can always reconstruct it, right? Or if you're out in the field doing engineering, if you happen to be an engineer, okay, or whatever you're doing, and you need this, and you kind of forget it, you don't have to go to all the trouble of going to Google and asking about the Pythagorean theorem and reading it. Okay, you have it in your head, and you understand it deeply, right? So that's what we're trying to achieve. Not everybody can do that, and there are a lot of people that can still do really good things that can't internalize this as easily as others, okay? That's okay. But we want to kind of emphasize the usefulness of being able to understand this at a level of depth. And what did I do here? I did something really, really stupid. This is not true, is it?
Why is it hypotenuse squared?
It shouldn't be.
Because it's
Either
supposed to
I
be
got
the
to get rid of
distance
that
formula.
square or I got to get rid of that square root, right? Okay, so there's a step missing here, but you can fill that in, okay? I just wrote it down carelessly. It was squared up here, and I do that. You got to watch me, okay? If I see the square there, I might write it down and not even realize I've written it down. So I've always got to look back and debug my own expressions. So, help me out with that, okay? Anyhow, that's what you're going to get. You get hypotenuse squared equals this without the square root sign, or hypotenuse is the square root.